Okay, homework 1 is on a couple things, the fundamental counting principle, permutations, and combinations. So this first section is on the fundamental counting principle. So you've got a certain number of things that are happening, might be 2 things, might be, 20 questions on a test or something like that. But the point is each one of those things has a certain number of possible outcomes, and you end up multiplying those possible outcomes to see what the total number of possibilities are for the entire scenario. So let's look at number 3. So an internet passcode, nice short passcode, consists of a digit followed by a letter followed by another digit. So digits are 0 through 9. So how many different passcodes are possible? So the possibilities for the first digit, the digits 0 through 9, there are 10 possibilities, followed by a letter. There are 26 letters, followed by another digit. So there are 10 digits. So how many different passcodes are possible? You multiply all those things together. So 10 times 10 is 100. Times 26 would be, so 2,600. So that's why passwords are supposed to be long and crazy complicated, because this is not actually horribly far off for someone to be able to guess or eventually figure it out if it was that short. The next set, so this is basically just practicing with factorials and with these different formulas and things like that. So let's do one of the permutations and one of the combination formulas. They are slightly different from each other. So we've got the permutation formula first. So number 11 is 20 permutation 4. So the formula is this. So this is your n, and then this is your r. So the formula is n factorial divided by n minus r factorial. All right, so this ends up being 20 factorial divided by 16 factorial. Remember, the way this works is you have everything from 20 down until you hit this value. So it would be 20 times 19 times 18 times 17. And then everything 16 and below would cancel with the denominator. So we have 20 times 19 times 18 times 17. So that would be 116,280. All right, and then the combination, you've got a slightly different formula. This one is n factorial and then divided by r factorial times n minus r factorial. All right, so these ones you can cancel out, like everything from 8 down. So the numerator, you'd have 15, 14, 13, 12, like down to 8s. And then in the denominator, you would still have 7 factorial. All right, so this, we have 15 down to 9. And then in the denominator, all the way down. That. So 6,435. Okay, and then let's do a couple on this next page. Okay, so we've got Scott completing chores. He has 7 chores to complete this Saturday. How many ways can he arrange the order in which he does them? Okay, so they talk order. Order is important. That makes it a permutation. So if we're going to solve this, you've got 7 choose 7 using a permutation. So he's got to use all of them because he has to do all of his chores. It's just a matter of what order he wants to do them in. So remember our little sneak formula here. This is actually just 7 factorial if these values match. And you do have a button for the factorial on your calculator. So you've got this in decimals. I don't know if you have it on just like a regular phone. Okay, so this is 5,040. So lots of different ways he could choose to do his chores. Oh, sorry. Let's do number 17 as well. There are 16 different colored markers. How many ways can Kelly choose 5 of them? This doesn't have anything to do with order. It doesn't matter what order she's putting the markers in. So this is just a combination. So 16 choose 5. So numerator, you've got 16 factorial and then r factorial and then 16 minus 5 factorial. So again, you do have buttons for those on your calculator. So set up a fraction, 16 factorial, 5 factorial times 11 factorial. Whoops, shoot. There we go. All right, so we get 4,368.